Here is a video on square roots. I'm going to study first principles of square roots in this section here. This video number 15, part 1 of 5. I've split that video on square roots in 5 parts, and this is the very first part. Okay, let us continue. Okay, let's look outline here, please. Square roots, we will discuss what square roots are. Then we'll look at first principles of square roots. Then we'll go through square roots by observations, square roots of small perfect squares, square roots from vertically and crosswise multiply, square roots from vertically and crosswise divide. Then we'll introduce quadratic equation and see how they relate to square root problems. What's a square root? Square root is inverse of a square. In other words, if x is a square root of n, then x square is equal to n. Alternately, square root of n is solution of x squared equal n. If determine the value of x in equation x squared equal n, we are trying to find a square root of n. Let's continue here. Let's study first few squares. Okay, number, we're going to look at some numbers, their squares, and digit sum of the squares. Okay, let's continue here. 1, first number is 1, its square is 1, its digit sum of the square is 1. Okay, let's continue here. Number is 2, okay, its square is 4, digit sum of square is 4. Let's continue here. 3, number is 3, its square is 9, its square root square digit sum of square is 9. Okay, let's continue here. 4, 16 square, and 7 is the digit sum. 1 plus 6 is 7. Let's continue here. Number 5, its square 25, and digit sum of 25 is 7. 2 plus 5 is 7. Let's continue here. Number is 6, square is 36, and digit sum of 36 is 9. 3 plus 6 is 9. Let's continue here. 7, number is 7, square is 49, 7 plus times 7 is 49, and digit sum is 4. 4 plus 9 is 13, 1 plus 3 is 4. Let's continue here. 8, number is 8, square is 64, digit sum of 64 is 1. 6 plus 4 is 10, 1 plus 0 is 1. Let's continue. Number is 9, square is 81, and digit sum of 81 is 9. Okay, let's continue here. Number is 10, square is 100, and digit sum of 100 is 1. Let's continue. Number is 11, square is 121, and the digit sum of 121 is 4. Let's continue here. Number is 12, square is 144, and digit sum is 9. Let's try to find a pattern. 1, 4, 9, 7, 7, 9, 4, then 1, 9. Okay, so this is sequence here. 1, 4, 9, 7, 7, 9, 4, 1, 9. Then it repeats 1, 4, 9, and next is a 7. Okay, and next is 7, next is. Okay, let's move into the next section here. And next section is first principles of square roots. These are axioms related to square roots. Let's continue here. Now, well-known first principles. I got these principles from Tirthaji's book. Perfect squares do not end in 2, 3, 7, or 8. If a number ends in 7 or 8 or 3 or 2, it's not a perfect square. Digit sum of perfect squares is not in 2, 3, 5, 6, and 8. Okay, digit sum of perfect square, you can have 9 possible values, and 5 of those are forbidden. Only 4 of the other. 1 is allowed, 4 is allowed, 7 is allowed, and 9 is allowed. Let's continue. If perfect squares end in 1, its square root ends in either 1 or 9, and the two are tens complement of each other. 9 is equal to 10 minus 1, and 1 is equal to 10 minus 9, and 1 plus 9 is 10. Okay, these are self-complementary. They are tens complement of each other. Okay. A perfect square ends in 4, its square root ends in either 2 or 8. Again, the two are tens complement of each other. 2 plus 8 is 10. A perfect square ends in 5, its square root ends in 5, and 5 is its own tens complement, so it does not have another digit to worry about, only 5. Okay, its tens complement is also 5. Okay, let's continue here. A perfect square ends in 6, its square root ends in either 4 or 6. Again, 4 and 6 are tens complement of each other, so either 4 or a 6. Let's continue. Okay, let's continue. A perfect square ends in 9, its square root ends in either 3 or 7. Again, 3 and 7 are tens complement of each other. Let's continue here. If a perfect square ends in 2 zeros, its square root ends in a 0. Okay. If a perfect square ends in a 0, it must end in even number of zeros. For each pair of digits or part thereof in a perfect square, there is one digit in square root. Continue here. If in a pure fraction like 0.23568 has n digits, its square has 2 times n digits. Exercises. Using the observations studied so far, determine if the following can be perfect squares. Okay, let's continue. First example, 41503, 50178, 2354, 37093, 53384, and some more. Okay, let's continue here. The first reference is Vedic Math Teacher's Manual, which is elementary level by Ken Williams, and you can get this book from vedicmaths.org, and PDF form is free. Okay? Let's look at next reference now, please. Vedic Mathematics by Bharati Krishna Tirtha Ji. That is the primary reference on Vedic math. That's the original and primary reference, and Bharati Krishna Tirtha Ji is the developer of Vedic math. Let us continue. Next is Discover Vedic Math by Ken Williams. This is the most complete, authoritative, and book with a consistent notation. Okay, let's continue here. Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover used these books in his school. These have a very readable and cover most of the topics, okay, if not all. Let's continue here. Then Vedic Math for All Ages by Vandana Singhal. This is very readable book and does not cover as many topics as the Glover books do. Okay, let's continue.